For question number 2 on this 18-question packet, we are given the area. And as soon as we are given the area, and I know I have 2 legs, I know that I can find what I would call the included angle, the angle that's between those 2 sides that you're given. So I'm going to use the formula, area equals 1/2, and in fact this is going to be A times C times the sine of theta. So I know the area is 150 square inches. I know A is 20, C is 15. I'm looking for the sine of theta. Let's see, so this becomes 10. So I end up with 1 is equal to the sine of theta. So I know theta has got to be equal to 90 degrees. So I have a right triangle here. Now, I can find the area of that right triangle. I would prefer to turn it this way, 15, 20. So the area in this case is 1/2 base times height. So that's a 10. So that's not helping me. That's what I already knew. What am I thinking about? But what we're asked for is find the area of each of the 2 triangles formed by the perpendicular segment from B to AC. So I'm going to draw a perpendicular segment. And perhaps you remember your geometry enough to know that as soon as you have this situation, you've got some geometric mean action going on here. But perhaps you don't. So what I'm going to say is we have some work to do here. Now, I can figure out angle A by just using SOHCAHTOA. So I'm going to make use of this. This is A, B, C. So if I wanted to find angle A, going back over here, I'm just going to say the tangent of angle A is the opposite over the adjacent leg, and then I'm just going to use my calculator. So I'm just going to do, let me just make sure. So I'm just going to do inverse tan of 20 divided by 15. So I know angle A equals 53.13 degrees. So this is 53.13 degrees. And if I want to find the area of this, I have 2 choices. I can do base times height, right? 1/2 base times height. Or I can use this formula again. And I'd rather use this formula. So I want to find out what this side is first, so I can use it. So I'm just going to, again, use SOHCAHTOA, and I'm going to use cosine. So cosine of 53.13 degrees is adjacent leg over the hypotenuse. So x is going to be 15 times the cosine of 53.13 degrees. And again, I'm not going to round that. I'm just going to take the cosine of that thing, which is still in my calculator, which gives me 0.6. I'm going to multiply by 15. So x is 9. And then I'm going to say area equals 1/2 15 times 9 times the sine of 53.13 degrees. And I'm going to go back up here. In fact, I'm going to take the sine of that again, and then I'm going to multiply by 15. I'm going to multiply by 9. I'm going to divide it by 2. And so I know the area of this left-hand triangle is 54 square inches. So this is 54 square inches. And I already know the entire triangle, right? This has an area of 150. So I'm just going to do 150 minus 54. So the other little triangle has an area of 96. And if you are interested in geometry, here's how you would do this using geometric mean. So once you know that this is a right angle, this is 15 inches, this is 20 inches, I can do Pythagorean theorem. I know the entire hypotenuse is 25. It's a 3, 4, 5 triangle. If I wanted to find out, let's see, I could find out this. I know a leg is the geometric mean between the whole hypotenuse and the adjacent part. This reduces, 2, 5 goes into both. That's 3, that's 5, that's 1, that's 3. So I know x is 9. This will be a 3, 4, 5 triangle. This is 3 times 3, 3 times 5. This has got to be 12. So then the area of this triangle on the left is just going to be 1/2 base times height 2 goes into 12 6 times, so this is 54. And then I could do the same thing over here. I know that this is going to be 16 because the entire hypotenuse is 25. So I could just do 1/2 base times height, and 8 times 12 is 96.